Hey, it's John and this is Gatti's Garage. Today we're working on our Panhead build, getting our air ride seat set up. If you want to see how we accomplish this, stick around. Alright, everybody, welcome back. Monday morning, back on the Indian Larry tribute Panhead build. Not sure what we're going to all get done today. As always, Mondays are kind of a short day for us. We're not really open. I try and jump in here and get a few hours in on this each Monday. Definitely going to measure up and draw the bracket for the seat airbags. That's number one on the list. Also going to probably draw the or begin to draw, at least anyway, the manifold, intake manifold. We're gonna run a couple kind of cool old carburetors on here. Have to make an adapter that bolts to the regular conventional intake manifold that will then adapt these two particular carbs we're running. Not gonna say what they are just yet. You'll have to stick around to find that out, but I think it'll be pretty fun. And once we get all those drawings done, we'll plasma cut the parts, and then I guess we'll see where the day takes us from there. That's what I got on the agenda right now. If that stuff goes relatively quickly, we'll get on something else, maybe a little bit more machining on the bridge for the front springer leg, or possibly, I'm expecting a delivery here this morning, possibly we'll have the material for the sissy bar and we'll start looking at getting that mounted up. So just kind of depends on how the day goes. Alright, so the bracket that came with this seat air ride system, I'm not exactly sure what it's designed for, but it just doesn't fit how I would want, so I came up with what I think is going to be something a little better. Obviously these bags, we want them to sit right in here, basically flush with the frame, and then when they air up, that'll pop our seat up and give you a little cushion to float on there. So I plan to just make a bridge strap across, down, up and over that will sit in this frame and hold these brackets. It'll be supported on both sides, which I prefer. This is supported only from the back, so you got a lot of leverage working against you. Again, I'm sure it would be strong enough, but it just doesn't fit how we want, and so this to me is going to be a better option. First things first, we got to figure out how we're going to get, I'm going to grab my notebook, the shape of the part we're going to make. I mean, this is not complex, you know. The key is getting all the dimensions right so that it is at the right height we want. So the overall dimension we're going to want is 8 3/4. And then we need to be the width to go inside this battery box area, so that we want to be 7 3/4. The last critical dimension is how much drop do we want this to have, which is pretty important. The good thing is we do have a pretty good amount of space here, so if we need to make a spacer or whatever, actually that might be preferable really, because it'll give us a little bit more clearance underneath. But anyway, it's all going to kind of be a little bit of a tricky setup, getting all this stuff plumbed and fit in this battery box, which is not going to be our battery box anymore. It's just going to be our electronics box. Our battery's going to have to go somewhere else. So the overall height of these when they're squished all the way down is 2 inches. So that tells us that we need 2 inches. And then when they're completely aired up, we got about 3 5/8. So that'll give us 1 5/8 of seat travel, which is, you know, about what you can expect on this type of setup. I mean, really, you could expect nothing. And then when we put it in here, we're just going to have to remember to put it in on a slight angle. It's a lot of little tricky things going on with this, but Yeah, okay. So then we're gonna need about a 2-inch depth. I'm gonna make it 2 1/4, and then if we need to add a shim to the bottom of the bag to fine tune it, we can do that. Just gives us some leeway. And then the overall width, we're gonna want to be the same width as this bottom plate on the airbag, just so it sits on it nicely, which is 2 1/2, a little less than 2 1/2, but we'll make it 2 1/2. And that'll give us what we need. Once we put our plate in here across, it'll tip it back on the angle we need. And then we'll figure out, obviously we're gonna have to make a seat pan and some kind of pivot hinge. This piece that's on the frame here now is kind of shoddy and worn out. I think I'll probably try and come up with something a little bit nicer, being that this is gonna pivot on air like that. Maybe we'll make a nice boss, put a needle bearing in it or something, or at least a bushing. You know, the factory Harley CTs at least had a bushing in them with a grease nipple, so I think we can do at least that good. But I'll probably put a needle bearing in it, because why not? All right, so anyway, we got our dimensions here. We're gonna head on over to the plasma table, get that drawn up, and see what we can come up with for that. And we'll also start drawing up our intake manifold while we're over there. So we got something a little new here. Figured out how to screen record on the computer, so you guys can kind of check out the CAD work we're doing. Starting to draw up the seat mount tab first. So once we get our initial tab laid out, we'll zoom out, you can see here. And then what I like to do is, at all of our bend points, I add a tiny radius on the edge of the part. This particular time, I did a 60 thou radius, so it's like a 1/16 hole. And I'll do that on each opposite side along the part at every bend. So on this particular part, it'll be at the 2-inch mark, then 4 1/4, then I don't know, 11 or 12. Anyway, it just steps across as you see. We're going to keep going. And what this does is, when it cuts out, it gives us just a slight divot in the edge of the part, nice and square, and it allows us to line those up with the press brake jaws and get a nice clean bend right across in all of our laid out positions. You could do it without this, obviously. You could, you know, mark it out after you cut it, but to me this is just a quick, easy way to get nice, even layouts and save yourself some time after you're done. So here we got our 4 bend marks. We'll use our line tool to lay out the end of this piece. Make a line. And then grab our trim tool and remove the excess from our initial rectangle drawing. Go ahead and save that and get ready to transfer it over to the plasma table. Alright, so the next thing we got to do is measure up our flange. The carburetor that was on the bike is an S&S. We're not going to be running that, but we'll go ahead and use this S&S I have here to figure out the dimensions and all of what we need. So I'm going to start out first with the center holes, 1/875. Actually, with 3 holes, I'm doing this. I'm kind of doing this backwards. Okay, so let's get rid of this. I'm going to delete that. We're going to start with 1 hole, random, anywhere, it doesn't matter. We'll go back and change the sizes of the hole. So we'll make a 1/2 inch hole. And then, because this flange and the bore of the carburetor and the 2 bolts are all evenly spaced center on center, I just happen to know that based on the carburetors. We're going to figure out the spacing on the 2. So we got 2.438. Somebody lost my regular calculator, so we got 2.438 plus, then you measure the inside of the 1 hole, 0.355 or 305. 0.305 is 2 3/4. So that's our bore spacing on these 2 holes. And then I like to just lay my caliper at that dimension and eyeball it, and it gives you a little confirmation that you are correct in your calculations. So now, in order to do this, we're going to go here. We're going to go to our linear pattern tool on our CAD software. We're going to want 3 holes. We want them to come back down this way, 180. And we want our total spacing to be 2.75. So now we've got our 3 holes. We can just select this one, come back in here to the diameter, and go back to the 1.875. That gives us our center bore there. And these bolts are 3/8. So on the plasma table, which is what we're going to cut this on, it doesn't make the nicest holes, especially this small diameter in the thick material. So I'm going to just go ahead and make these 0.3. Actually, I'm going to make them 1/4 inch, 0.25. And then we can run a drill through them after we're done. We'll have them located, but it'll make a nice clean drill hole instead of kind of raggedy cut plasma hole. So now that we've got that, the next thing we got to do is get our outside shape down. You want to have something that looks, you know, pretty close to this. So I'll measure the outside width of this, which is about 2.56, so 2 inch 560. We'll go back to our circle tool, we'll find the center, and we'll go 2.56. That gives us our outside dimension there. And then the same thing here. It's a little trickier because you don't have really a round circle anywhere. So what I like to do is go from the center of the bolt to the edge. And that's a 1/2 inch. So then if you figure a 1/2 inch all the way around, which it looks like we have the clearance for, that'll give you a 1 inch circle around the outside of your small bolt holes. So again, we'll go back to center, bring a circle out, come over here to our diameter, you go 1 inch. Same thing here, 1 inch. And then we'll get our trim tool and we'll start taking off all the parts of this that we don't need. Obviously this kind of joins it all together to make it into essentially one piece when we cut it. Oop. So as you can see, as we get the pieces out of the way, it gives us our holes that we want. So essentially this would work now, but it looks ugly. So what we're going to do is come back in with our line tool and pick a spot. We'll try to pick up the tangent here, which looks like it might be right there. and then we'll bring it up to here on your edge. That gives us, again, another, just a cleaner look on our part. So we'll do that all the way around. Find our edge. Find our edge. I don't like that one. We didn't really get it in the right spot. So you want to watch all your little indicators when you can on the CAD program, at least if you have a CAD program. Like, see that blue line here that you can kind of see? That makes you know, or lets you know, that you're in the same spot from side to side. So it lets you, helps you get a symmetrical drawing. CAD is like, the guy who trained me on CAD told me something which is very similar in everything. There's 1,000 ways to get where you're going doing a CAD drawing, and I am by no means an expert at CAD, but the thing he told me, which really made sense, is just draw it however it makes sense to you to get the job done. If it makes sense to you, it's going to make the, get your part made. Just do it that way, which, made a lot of sense. He worked for the company I bought my plasma table from, Maverick CNC, and this software that came with it was just, this is the reason I bought the table. It was a lot more expensive than any of the other softwares, but when we get this drawing done, I'll show you why, or at least what I think. So most of the other tables that I'm familiar with, you draw in some kind of CAD program. A lot of guys use Fusion 360 or whatever. Then you have to export it into some other kind of program for your cam. I don't know. There's a whole bunch of different ones. I'm not really familiar with any of them because I've never used them. Then after you do that, you have to put it into something else to create your G code. So it's a really convoluted process. You get a lot of times, you get errors. You also need to then put it into something else to nest it if you're cutting like multiples of the same part and you're trying to get efficiency in your material usage and whatever. So this particular program is everything all in one. So it's the CAD, the CAM, and the CNC control. And literally, like, okay, we got our drawing done now. You can see, our 2 undersized holes, our center hole, outside dimension looks very similar in shape to our S&S carburetor, which is exactly what we want. And boom, you click here, and it sends it over to the CAM. You can see it's got our tool paths generated. You can come up here. We enter in, I'm not going to do this right here because we'll have to move this out to our computer that's on the actual plasma table, but you have your kind of materials, you have thicknesses, you go here, you have the machine settings for all the different plasma cut settings. It sets all the control parameters, the feed rate and everything. It sets it all for you. You can nest, like if we wanted to get 5 of these or 7 of these, start nesting, it nests it right on here for you. I mean, it's just very very user friendly. I had never done any kind of CAD work or anything, and this worked for me. Boom, you click it on the CNC, you can see it produces our G code, shows you all your controls, blah blah blah. This is more useful out on the actual machine than in here in the office drawing, but I think you get the idea. It's just a great software. I can't say enough good things about it for beginner people. So that is that. We got one more thing I want to add on to here. So this, because we're going to run the 2 carburetors, this is going to have a cable splitter. So I ordered one, but it's not here yet. But I'm going to look here and see if I can see what the dimensions of it are. I want the cable splitter to be able to mount in the manifold just to keep everything nice and clean. We won't have cables flopping all around. 1/16. I'm going to guess this is probably 3/4 inch OD. We'll set the drawing up. I'll undersize it like I did with the bolt holes, and then we can finish dimension it to that. But I'm gonna set those dimensions like that, and hopefully that'll give us what we need. So what I want to do is add another mounting hole on the top here to give us a place to mount the splitter, and then I'm hoping we can run some hard cable outside sleeve we'll make out of some stainless steel tubing instead of crappy looking black throttle cable. So I'm going to use this 3/4 for now. I'm going to bring it in pretty close because we don't have a ton of space. And then let's see, probably go 1 1/8 on the outside. That'll give us a decent enough wall thickness, because what I'm gonna end up side drilling this and putting a little set screw to hold it in. So that's my plan for that. Going to do a small radius on this, I think, if it looks right. We're going to try that out and see. So if we bring that to here, that looks okay. And then we'll bring that to here. Oop, missed. Alright, there we go. Again, come back with our trim tool, get all this extra parts out of the way, because if you leave those lines in there when you go to try to cut, it's going to give you trouble. Okay, so I'm going to drop this down in size to 1/2 inch, just so we have some room to open the hole up to the size we need. And we'll run our fix tool, make sure everything looks good. Yeah, we got a couple little overlaps there. That happens sometimes when you do so many lines overlaid. So just go ahead and fix those. Then you come back in here. I like to zoom in. You take your trim tool, you can kind of hover around, see if you have any little pieces, any stragglers. You zoom way in, and it doesn't look like we do. And then the last check on that is when you shoot it over to the cam, if there's some weird lines in there, you'll see a bunch of tool paths, like trying to cut little tiny cuts there and there, which it doesn't look like we have. So then we're just going to come here, we'll save, we're going to do Indian Larry Panhead intake number 1, in case there's some more pieces. All right, there we have it, our roughed out intake manifold. You can see what I mean if you look real close, how the holes are pretty jagged. Obviously the larger the hole, the better it is. But this will all get cleaned up. Obviously we still have to make a intake spigot and the other things that we're gonna need for the other carburetors to mount, but I don't have the carburetors yet. They are on order. Once they get here, we'll continue on with the rest of this. Obviously, we'll bore this out to the correct size and fit our splitter and everything like we talked about, but you can see that's just the rough cut there. All right, so now we're gonna go ahead and cut up our air ride seat strap. All right, as you can see, the Maverick CNC plasma table makes real quick work of this. Something I wanted to show you guys when we were drawing it on the table, you probably saw, but I put these little tiny notches in it. That gives us our reference for our bend points when we get over to the press brake. So we'll go ahead and get this cleaned up. We'll get it bent up and check the fitment on the bike. Alright, so there we got our airbag mount bent up. We'll have to head over and test fit it on the bike. Alright, so we got our piece. And man, it drops in just how we wanted. I did make these ears an inch longer on either side just so we had a little bit of room to dial it in if we needed to make adjustments, which actually it looks like if I hadn't have done that I would have had it perfect, but I always, you know, when you're making a part with bends like this, it's easier to have a little piece to trim off if need be. So anyway, next thing we got to do is line up our holes to mount the bags on, which shouldn't be too hard because we can use this here as our pattern. So we'll go ahead and flip that over, lay those holes out, and head over to the drill press, get those cut out, and come back and see about mounting this stuff up. Alright, so we got our holes drilled. And throw our airbags in here. I did make these oversized because I want to be able to shift stuff around a little bit once it's mounted top and bottom, just in case it gives us any binding in our action. We'll use a nice washer underneath here once we get them all. You know, this is all just mock-up, but it'll just give us a little bit of floating room, which I thought would be possibly important once we get everything set up. So anyway, we got our bags. We got this. I'm going to go ahead and mark these underside holes along our frame. So I'll tell you one thing that's looking a little bit interesting here is how all this is going to come in and out of the bike. It's going to be a little bit of a jigsaw puzzle, I think, where, you know, one piece has to go before the other, and if you get that wrong, you're going to be SOL for getting it out. But luckily none of this stuff is stuff that will frequently need to come out, so just the nature of it. Sometimes when you're building these custom bikes that have a lot of little intricate parts, that it'll make it tricky to assemble. So. Alright, so there we have it. We got our airbag strap. You can see these are going to drop right in here. Obviously we'll push this a little bit further forward so that we don't have any airbag rub on our fender mount there. Should be able to still tuck our air compressor in underneath in the oil tank. And this is what they gave us to mount to the seat. So this may actually still work now that I'm looking at it. This will bolt right to the airbags there pretty nicely, since we used our other part to line up our bag mounts there. So we got that there. Not there. And then that's going to give us our mounting point for our bobber type seat. We are going to custom make the seat because I want it to roll in here real nice up to the fender. I'm not going to buy one of those seats. It's just, this bike deserves better than that. So, but yeah, so overall I'm real happy with that kit. You know, the one bracket I didn't like, but that's kind of to be expected. Honestly, I guess thinking about it, do I like buying the kit versus just buying the two separate airbags from like an industrial supply? I don't know. This bracket here is pretty nice. It's probably worthwhile, especially if you don't have access to a plasma table like we do. So, you know, take that for what it's worth. Alright guys, that's going to be a wrap for today. We got our air ride seat all situated. We didn't weld it on yet because I'm waiting on one other piece. I want to make sure it's going to fit underneath there in case we need to make a couple of adjustments as far as air ride compressor goes. But other than that, I'm real satisfied with it. I think it turned out great. It's going to be nice and sleek and add a little bit of comfort to this rigid bike. We got our intake manifold cut out, or our intake manifold base plate rather. Unfortunately, no stainless steel round bar in the mail today. Holiday time, you know, makes for a mess with shipping as always. So that's that. I'm out of here. Hope you guys have a great week, and we'll see you next time at Gatti's Garage.